Hello, everyone. Today we are going to talk about autoscaling. What does it mean, how it's used, which tools use. Covers the basic concept of scaling as well as tools we can use. On the next slide, we a little bit introduce to Kubernetes scaling and what is this Kubernetes. And the problem is that today we will not even touch on 20% of what is Kubernetes, but today we are going to talk about scaling our programs. So let's look at two minds of type of scaling, like two pillars. The first is like horizontal pod autoscaling, and the second it's vertical post autoscaling. To be honest, it's this is not all autoscaling type, but it's main of Kubernetes. Automatically, let's try to check what is mean horizontal pod autoscaling. For that moment, in our project, we use horizontal pod autoscaling. It's automatically adjustment the number of pod instance in a deployment, and the second, it's the second main utility. It's the scale pods based on CPU utilization. Vertical pods, it's more hard use on a big project because this solution take a lot of resources and need to write instruction about every pod which we use, because when you have big pods, little pods need to write providers. And now I show you two main tools for scaling in Kubernetes. The first is Cluster Autoscaler. In our project, we use Cluster Autoscaler. Cluster Autoscaler looks for pods that cannot be scheduled and not then are unutilized. After that, it's like just a text. Maybe I will provide you architecture, how it's work. For that slide, we see a pending pod, and Cluster Autoscaler looks for this pod and the simulates adding to removing nodes before applying the change to your cluster. The AWS could provide implementation in Cluster Autoscaler control the desired replicas and field on your EC2 instance or EC2 autoscaling group. The Kubernetes Cluster Autoscaler automatically adjusts the number of nodes in your cluster, like not one or two, and if when pods fail or reschedule to another nodes. For example, this nodes it's full, and Cluster Autoscaler get this pod to another node. AWS Autoscaling Cluster Autoscaler create a new big node, and AWS Autoscaler get this pod and put to a new node. Okay, the Cluster Autoscaler is like typically installed as a deploy on your cluster. It's old solution how to scaling our cluster, but for that moment, I'm not sure for that moment, but 3 or 5 years ago, Kubernetes create other tools for scaling. It's Karpenter. Karpenters works with the Kubernetes scheduler observing incoming pods around the lifetime of the cluster. In this screen, we saw small information what is in Karpenter, open source project, and it simplifies and automates manage node groups in your cluster. but let's go to another architecture image and check, and I will try to describe you how it's work. Carpenters work with not nodes. Carpenter work with spots. For example, if we have little pods, like based on cluster autoscaler, pick up a big node for these little pods. But Carpenter, if we saw a little of pod, he pick up a little nodes because we don't need too powerful server. And it starts to stop nodes to optimize application availability and cluster utilization. When there is enough capacity in the cluster, the Kubernetes scheduler will place to the incoming pods as usually. But when pods are started that cannot be scheduled using existing cluster capacity, Karpenter bypass the Kubernetes scheduler and work directly with your provider, like with your computer service provider. It's scenario how to pods pick up on your cluster. And after that, Karpenter start a minimum computer resource needed of these pods and associate these pods with provisioner node. It's a really powerful tools, but for that moment, a lot of documentation right for the cluster autoscaler, because when you use cluster autoscaler, you like more deeply set up your scenario, how to pick up nodes, how to pick up pods, and that's all. For that moment, I created a table which like side by side sorry, doesn't matter. I create a side by side compare, and for that moment, I will tell to you about more detail about this, like these words. What is this? Upscaling. Like for example, if you're using Karpenter, Karpenter offers more intelligent scaling capabilities to detect specific workloads requirements based on the device resource. By the way, for example, cluster autoscaler, it's focused more on node level scaling. Node pods, cluster more use nodes level. That means it can be add more nodes to the cluster to meet increased demand. The second pills, it's like down scaling. Karpenter offers more intelligent scaling capabilities to detect specific workload requirements based on the device resources, and this means that that it can scale up based on actual usage. But for example, cluster autoscaler focus more on the node level scaling. That means it can add more nodes to the cluster to meet increased demand. For example, before I told you about Karpenter, it's new technology, and Karpenter, it's really new solution but it's open source solution and still active development since AWS back to the Karpenter officially, but it may not yet have some levels of maturity or stability as cluster autoscaler. Because cluster autoscaler has a clear advantage that has been around for much longer than Karpenter. It is also battle tested in many production environments. It's a really well established and a reliable solution that can be optimized for variety of Kubernetes configuration and use cases. And the second is scheduling configuration. It's like main part of all this topic, all this presentation, because Karpenter can schedule workloads based on specific criteria. The criteria can be like resource requirements, availability zone, cost. It can optimize workload scheduling to cut cost and maximize efficiently, but might and more configuration and fine tuning to get scheduling right. Karpenter, it's really powerful solution, but Cluster Autoscaler, it's simplest scheduling. It's like simple solution for our project. It's desired to scale up or scale down, demand or spot node. Doesn't matter. It may not have the same level of scheduling as Karpenter, but is generally more reliable and requires less maintenance. The last, it's availability and installation. With installation, it's really interesting. We try to install this Karpenter to our infrastructure, but for that moment, we don't do that because we have old version with Cluster Autoscaler. And the main part, we have old version, some modules, which Karpenter need to use. And for that moment, I'm working how to upgrade our cluster and need to create new resources, need to update a lot of version resources. And the next, it's availability. Availability, to be honest, Karpenter, it's a really perfect solution because Karpenter built on top of Kubernetes because like it's native for that moment, it's native component in Kubernetes. It's designed to be available and fault tolerant to the Kubernetes. This means that Karpenter use Kubernetes robust infrastructure. Also, Karpenter failover mechanism to ensure that is a way up and like running some pods and downscaling some pods. But Cluster Autoscaler, it's standalone tool, like near availability. It can be installed on many clusters. A lot of big corporation using Cluster Autoscaler. It also has a mechanism to ensure high availability that includes leader election to automatic failover. But since it is not integrated with Kubernetes like Karpenter for that moment, because mostly Cluster Autoscaling working with AWS Autoscaling group. And for example, Karpenter working like with Terraform or with Kubernetes configuration. So it may need to more like when we use Cluster Autoscaler, we need to more manual intervention and maintain availability to certain situation. This is if you want, I will describe some steps on these slides. And for that moment, that's all.